Okay, so the last part of these notes is dividing with radicals. All right, so an expression containing square roots is simplified when there are no fractions inside the radical sign. So one thing that we could do with them, just like with multiplying, like I could take two separate radicals and I could multiply them together as one. I can kind of do the same thing here. I can take a giant radical. The first step we're always going to take is if you have that giant one, I want you to split them apart. Okay? Students who just leave a big one forget that that's also on the bottom, and then they make a lot of mistakes. So first thing, we're going to split it so I can see it on top and I can see it on the bottom. And then we're allowed to go ahead, if they're both under radicals, you can divide them or simplify them just like in any normal fraction, okay, as long as they're both under the radicals. All right, so down here like this one, it was radical 3 over 4. So then they split it to radical 3 over radical 4. So radical 3 I can't really do anything with, but the square root of 4 is 2. Okay, so we can split them apart and then kind of do them separately. Now, oh wait, never mind. I have had another thought that's later on in the notes. All right, so let's go ahead and practice a couple. So number one, first thing, anytime you have the giant radical, we want to go ahead and split that apart. So that's going to be radical 16 over radical 49. Can I take the square root of 16? Yeah, what's the square root of 16? 4. Square root of 49? Good. And 4/7 is as simplified as they can get. Now, if they all were that easy, this section would be a piece of cake. But you know it's not going to happen that way, right? All right, so number 2. First thing, though, giant, tall radical. Let's go ahead and split it. So radical 2 over radical 81. Square root of 2? If I do a factor tree on that? Anything? No, it's just square root of 2. And then square root of 81 is 9. So we're good. Now, some students have a tendency to want to reuse their radicals. Like on this one, I have students every year who take the square root of 16 as 4, and then they put the radical over top of it again and then turn it into a 2. You can't do that. And the people do it here all the time, too. They try to turn it into a 3. If you hear me tell you that you're being gross and you reused your toilet paper, that's what I'm referring to. I know it's really gross, right? Think about it. If you go to the bathroom, your toilet paper, are you going to keep it and reuse it later? Or are you going to get rid of it? I hope you're getting rid of it, right? I know it's disgusting. Now everybody's got that thought in their head, right? But that's what people are doing with the radical. Once you've used the radical on something, it's gone. You don't reuse it again. So if I look at you and I'm like, gross, you just reused toilet paper, that's what I'm referring to. Okay? Now that that thought is in your mind, hopefully that helps you remember not to do that. All right, number 3. First thing, let's go ahead and split it apart. So radical 8 over radical 25. All right, square root of 8. Can I simplify it? Yeah. So we'll have to do the factor tree. So that's 4 and 2 and 2 and 2. So I have a pair of 2's which come out, a leftover 2 which goes in. Okay, can you simplify the bottom? Radical 25. That's just 5. All right, and then 2 over 5, these are numbers not in a radical. If they simplified, we could do that, but in this case, they don't. So we are done. All right, so it's possible that you end up with a fraction that all your radicals are gone. We like those. Those are the easy ones. Number 2 had a fraction where one of them still had a radical and one didn't, so that was okay. And then number 3, it wasn't perfect, but we could simplify it still. Right? We always want to look, no matter what the number is, if I do a factor tree, are there any pairs hiding in there? Okay, you always want to look for that. Okay. So in math, sometimes there's weird rules that, for whatever reason, they've established at some point, this is how it's going to be. And this is one of those rules. Okay? We cannot leave a radical in the denominator. It's considered not simplified. It's like worse than leaving 2/4 on a page instead of simplifying that to 1/2. okay? You cannot leave a radical in the bottom. So for this example, they had radical 4/3. They split it first, just like we have been, simplified the 4 to a 2, and then I couldn't do anything to the radical 3. But because that's a radical there, it's considered not simplified. We cannot leave it that way. So what we need to do is called rationalizing the denominator. In math, the harder something sounds, typically the easier it actually is. This is actually not a very hard skill for you guys to learn today. Okay, so we're starting here where that one left off. Whatever the radical is on the bottom, you will multiply top and bottom by that radical. Okay, so on top, 2 times radical 3, it's just 2 radical 3. One's in a radical, one's not, so they can't actually multiply and change that value. On the bottom, radical 3 times radical 3 is radical 9, and the square root of 9 is 3. So my radical in the bottom is now wrong. Could you simplify this 3 with that 3? No. That one's under a radical, that one's not, therefore they don't work together. Had they both been under a radical, then yes, they could work together. Okay? Now, me being a lazy mathematician, I go through these steps with you guys so many times, and then I get irritated that I have to keep writing things. So let me kind of throw something out here for you guys. If I have radical 5 times radical 5, what do I get? I get radical 25. The radical's still there because I haven't taken the square root of anything. And then the square root of 25 is 5. Okay. So if I have radical 11 times radical 11, what's that give me? 121. There you go. And the square root of 121? Anybody noticing anything? Radical 7 times radical 7 gives me radical 49. Square root of 49 is 7. Yeah. Yeah, if you multiply 2 of the same radicals together, you're going to end up with a perfect square that the square root of it is just whatever those numbers were. Now, I hope that you start to recognize this pattern so that I'm trying to help you guys out, save you some time in writing. But if you don't, that's fine. But I also have students every year who are like, oh, they just cancel out and it goes away and there's nothing left. And no. There's a number there for sure. It's just the number without the radical is what ends up happening. Does that make sense? So if I ask for the square root of Emma times the square root of Emma, what's that equal? Emma. Look at that. You just got to use a math class. All right. So number 4, 7 over radical 5. So our first step was always to split the radicals if we needed to. Do those split? No, there's not like a giant radical. Okay, so I don't have to split anything. All right, can I simplify the radicals or the fraction? Radical 5 doesn't split to anything. Okay, and then I have to look at, do I still have a radical in the bottom? And I do, so I need to rationalize. So I'm going to multiply top and bottom by radical 5. So on the top, what is 7 times radical 5? 7 radical 5, good. On the bottom, what is radical 5 times radical 5? It's radical 25, which is 5. Can I simplify 7 over 5? Nope, so that means I am done. Okay, I cannot leave a radical in the denominator. So if you have an answer that you're going to circle on your page and there's a radical in the bottom, wrong. I don't have to look at anything else, I just know it's wrong. All right, number 5. 6 over radical 6. All right, can I do a factor tree on the 6 and get any pairs? No, 6 is just 2 and 3, so there's no pairs there. All right, but we can't leave a radical on the bottom. So we'll multiply top and bottom by radical 6. Whatever that radical is, that's what we multiply by. All right, so on the top, 6 times radical 6. 6 radical 6. On the bottom, radical 6 times radical 6 is, it's radical 36, which is just 6. Is that done, or can I simplify something? It's just radical 6, right? Because I can cancel out this 6 with this one. So it is literally just radical 6. Okay? Number 6, radical 10 over radical 3. Can I do a factor tree on the 10 and get any pairs? Factor tree on the 3 and find some pairs? No. All right, so we'll go ahead and rationalize. Multiply top and bottom by radical 3. What's radical 10 times radical 3? Radical 30. Good, those can actually multiply because they're both under a radical. Radical 3 times radical 3 is, it's just 3, right? It's going to give you radical 9, which is just 3. Can I do 30 divided by 3? Why not? Good. 1 is a radical, so those don't actually divide. Am I done, or is there any pairs hiding in the 30? If you did a factor tree on this, it would be, what, 3 and 10, 2 and 5. Is there any pairs there? No. So that means that's as simple as it can get. But we always want to get in the habit of checking that, okay? Okay. Number 7. 5 radical 2 over radical 15. What should we do first? What did you say? Can I divide 2 over 15? No. Okay. Can I do any factor trees on my radicals and get some pairs? Are you guys alive? Are we awake? I feel like I'm talking to Dylan today. All right, good. I can't do any factor trees there. So once you've kind of exhausted every possible way to simplify, then we try to rationalize, okay? I have some students that will jump in no matter what the problem looks like, and they'll rationalize first, and oh my God, their problem gets big and ugly, okay? Simplify everything you can first, then rationalize if you have to. All right, so on here, we're going to have 5 radical 2 times radical 15. What's that give me? There you go. And on the bottom, radical 15 times radical 15 is 15. Now, for those of you who are like, what did he just do? That would give you radical 225, and then square root of 225 is 15. Now what? Am I done? Or can I simplify? Numbers not in a radical, they can work together. Does 5 over 15 simplify as a fraction? What's it become? That's 1/3. And then I still have the radical 30. Again, I can't use it to simplify with something else because it's in a radical, the other numbers are not. And we just established on the last problem that if I did a factor tree on 30, there's no pairs in there. So we are done. All right, let's kind of real quick, let's stop for a minute. I know some people like step by step. So let's kind of throw this out there. That way you can't come back at me later and be like, well, you never told me I should do that first. I'm going to tell you right now. Okay, we're going to write it down. So first thing we want to do always is split the radical. And again, it doesn't happen on every problem, but if it does, we want to make sure we do that. So we're going to split the radical, meaning if you have this big giant fraction, I want you to split that to a fraction with radicals on top and bottom. Okay, so that's the first thing we should always do if that situation presents itself. After that, we're going to try to simplify the fraction or divide. It just kind of depends on what the problem looks like. But you always want to simplify everything you possibly can. Your numbers stay smaller and it's easier to work with. Okay, so after you've simplified everything you can, then you want to try to do factor trees on your radicals, looking for pairs, right? Trying to simplify those. Then rationalize the denominator. That's where you're multiplying top and bottom by that radical. And then last, simplify again if necessary. All right, so there's kind of like your plan of attack, okay? But the biggest thing is do not rationalize until you've exhausted every possibility to simplify. If you do that, this section is not that hard. If you try to rationalize right away, this section is going to be awful. All right, so let's come back up to number 8. So number 8, I have the giant radical over a fraction. So what do I do first? Let's split it. Some people are so loud. All right, so let's go ahead and split this. Yeah. All right, so I split the radical. Next thing I'm going to try to do is simplify my fraction or divide the numbers, whatever kind of we're looking at here. Does 5 over 14 simplify at all? No, it doesn't. They're both under radical, so I could try, but in this case they don't. Factor trees on the radicals. If I do a factor tree on 5 or 14, do I find any pairs? No. Do I need to rationalize my denominator? Yes, because there's a radical still sitting there. So then I'll multiply top and bottom by radical 14. What's radical 5 times radical 14? Good. Good, over 14. Because again, on here, that's going to give you radical, is it 289? No, 2. Someone help me. What is 14 squared? Say it again. 196. Yeah, that wasn't right what I said. 289 is 17 squared, I believe. All right, and square root of that is 14. All right, so then last step, simplify again if necessary. So can I do a factor tree on 70 and find any pairs? It's going to be 7 and 10, and then that's 2 and 5, so there's no pairs. Can I divide 70 and 14 to simplify? Can they work together? No, one's under radical, one's not. So I am done. All right, number 9. I'm going to let you guys try on your own for a minute to see if you truly can follow the steps. If you get lost along the way, it's okay, we'll talk about it, but try number 9 on your own. Let's see how far we get. All right, so number 9, I think all of you did the first step, right? You all split that radical 27 over radical 8. Okay, so step 2, simplify the fraction. 27 over 8, does that simplify as a fraction? It does not. But most of you didn't do step 3. Can you do factor trees and find any pairs? Yeah, you can. So on the top, I'll do a factor tree, 3 and 9, 3 and 3. So we got a pair of 3s and a leftover 3. Okay? 3 of you in a row did that, and then you didn't do a factor tree on the bottom. So, but I can do a factor tree here. That's 2 and 4, 2 and 2. So I got a pair of 2s and a leftover 2. So that was me doing step 3. I did my factor trees on my radicals. I found some pairs and made my number smaller and simplified. Step 4, rationalize the denominator. What's the part of that denominator that's the problem? There's a radical. The fact that there's a 2 here, I don't care about the 2. The radical 2 is the problem. So when I'm rationalizing, I'm multiplying top and bottom just by radical 2, because that's the only part that was the problem. So on the top, what's 3 radical 3 times radical 2? Just 6? 3 radical 6? You guys are making me nervous. All right, like I had the 3, it's the outside number, the 2 radicals multiply to give me the radical 6. On the bottom, what's radical 2 times radical 2? It's radical 4, which is 2, and then 2 times 2 is 4. So it's 3 radical 6 over 4. Now, I saw some different methods going on. You could have still ended up at the right spots doing it a different way. If you were somebody, there's way different ways, and I want to kind of show you that. So it was, let me kind of move this down a little bit. So some of you had radical, yeah, that got weird, didn't it? Oh my goodness, it's moving everything I don't want it to move. All right, so if you had radical 27 over radical 8, some of you didn't do factor trees at all, and you just went right to rationalizing it. This is where yes, it will work, but you have way more simplifying to do afterwards than you would if you simplify first. So if I do this, what is this, radical 2 something? What is that? 216, thank you, over 8. And I saw some of you did that. But then I have to do a factor tree on 216. Is that a lot bigger factor tree than on an 8 or a 27? It's bigger, right? So I got 27 and 8, 3 and 9, 3 and 3, 2 and 4, 2 and 2. So then I'm looking for pairs. I'm like, okay, I got a pair of 2s, I got a pair of 3s, I got a leftover 2 and a leftover 3, so it's a radical 6. Okay, so that's 6 radical 6, and all of that was over 8. Still not done, because then I have to simplify 6 over 8. Simplifies to 3/4. So that's 3 radical 6 over 4. I can get there, but my numbers are harder to work with, okay? When I did it from the very beginning, a factor tree on a 27 and an 8, I bet you didn't even need your calculator to do a factor tree on those, right? And they're smaller, a lot easier to work with. If you do it later on, your numbers get bigger, and then you have more simplifying to do at the end as well, okay? All right, number 10. Square root of negative 63 over 52. What should I do first? Thank you. Oh, you guys really don't talk to me. Did you? I did. Sorry, talk a little louder. It's all right. All right, so we're going to go ahead and split the radical. Yes. Take a look at the top there, guys. You have a negative under your radical. That's an I. So, all right, I'm just going to go ahead and kind of cross them out and go in front so I lose track of it. All right, so steps 2 and 3, so important, guys. Simplify what you can. 63 over 52, does that simplify as a fraction? And again, you have calculators, you could type it in. 63 over 52 as a fraction, hit equals, does it simplify? No, it does not. All right, okay, so your next step then is to do your factor trees, right, on each one of them. So 63 is going to be, what, 3 and 21? And 3 and 7? Okay, so I got a pair of 3s, so don't lose your I, and a leftover 7. Then we'll do a factor tree on the bottom. It's 2 and 26, 2 and 13. So I got a pair of 2s and a single 13. Okay, so I simplified everything I possibly could. Now what? Good. I had to rationalize, which is getting rid of that radical. So it means I multiply top and bottom by radical 13. So on the top, 3i radical 7 times radical 13. What's that going to be? Very good. And on the bottom? Yeah, you're right, 26. Radical 13 times radical 13 gives me radical 169, which is 13, times my 2 that's already there, is 26. And then it said to simplify again if possible. Does 3 over 26 simplify? No. If I do a factor tree on 91, 91 came from 7 and 13. There's no factor tree of pairs there, so we are done. Now, for those of you that are like, I'm just going to rationalize right from the start, not a big deal, right? So if you rationalized from the very start and multiplied top and bottom by radical 52, you'd have radical negative 3,276 on top. That's a big number. I wouldn't want to mess with that, okay? So the more simplifying you do early, your numbers stay small and manageable. All right, so number 11. All right, so I don't have to split it. It's already split as two fractions, or two radicals there. So next thing, can I simplify? It says negative 36 over 48, simplify. To what? Good. All right, so the negative's still out in front, right? And this was, what did you say, negative 3 over radical 4? 36 over 48 is 3/4. So is there an I, yes or no?
Yeah.
Yes, there is an I. So this is going to be gone and the I is going to come out. Can I do a factor tree on the 3? No. So I have negative I radical 3. And then on the bottom, what's the square root of 4? That's just 2. Yeah, 36 and 48 can both be divided by 12. That's where it's getting down to 3/4. Yeah. What's the square root of 4? I can't take the square root of 3, and I can't do a factor tree on it, so there's nothing I can do. Radical on top, totally fine. Radical on bottom's where it's bad. But look how really little work that problem required. What if you rationalized it first? Yeah, if you multiply top and bottom by radical 48 to start, that's a lot of work, okay? Simplify things first, and it's so much easier. Questions on this one? I think some of you were thrown a little bit. Are we okay? All right, number 12. Try this one on your own. This problem was a little frightening for some of you. Let's talk, shall we? All right. Step 1 is to go ahead and split your radical, which these are already split, so we're good there. Second step is to simplify or divide, right? To kind of make your number smaller. Negative 40 over negative 6. Two negatives make a positive. And then 40 over 6 becomes 20 over 3. Now, the radicals are still there because I did not take the square root of anything. All I did was simplify the fraction. I saw some of you pull the i's out. If you have an I on top and an I on bottom, what's going to happen? They're going to cancel out anyway. So if you pull the i's out, that's fine. Just recognize they do cancel. All right, next step, step 3, is to do your factor trees on each radical. Okay, I can do a factor tree on 20, and I can find some pairs. So we have a pair of 2's, and I have a leftover 5. Factor tree on the 3? No, I'm not going to get any pairs, so that stays a radical 3. And then I have to rationalize. So I multiply top and bottom by radical 3. So on the top, I'm going to have 2 radical 15. On the bottom, radical 3 times radical 3. Good, it's just 3. Right? That's going to be radical 9, which the square root of 9 is 3. Nothing else simplifies, and I am done. Now, walking around, many of you still did not simplify first. Guys, I don't know what else I can do besides like beating you in the head to get you to simplify first, okay? It is so much easier to simplify first. Can you still do it if you don't simplify first? Yes, you can. But the problems get really big and ugly, and you just don't want to go there, okay? Ben?
I did that.
Okay.
That's why.
Thank you.
I didn't get 20 and 3. I got like 6. I can't remember what I got, but that's why.
Okay. And again, Can you still do it if you don't simplify first?
Yeah.
Yes, you can, but they're way harder. Okay? So always try to get that in your head to at least look for it. Even if you maybe miss it on a problem, look for it. Okay? All right. Other questions, guys?